All right. So welcome everybody to How to Kill an AWS Access Key. So my name is Benjamin Herring. I lead the security engineering team at a company called ASAP. And a couple of quick ground rules before we start going off. Copies of the slide for this deck are already uploaded as a PDF attachment to the Sketch event for this particular talk. So if there was anything that you missed, didn't get the picture, just go download the PDF slides. Also, as you guys have been hearing, we're using Slido with the hashtag BSidesSF 2020. If there are questions that you have for me, if I do my timing right, there'll be like 5 minutes at the end for any questions. And if we run out of time or you want to give me snarky remarks or all the rest of that, I will be glad to read anything you want to throw at me at Twitter. You can throw it at my handle, which is off the side of the screen. Thank you, IMAX. All right. So let's talk AWS Access Keys. So AWS Access Keys are probably the simplest and easiest way to understand authentication with the AWS APIs. Gets your developer from nothing to being able to access everything in like 10 seconds. When you use AWS Configure, the first thing that it asks you for is, hey, what is your AWS Access Key? But they have some problems. So they're static. They hardly ever get rotated. If they ever get rotated, maybe they get rotated whenever you lose an employee and gain a new one. They're always on disk in plain text. And unless you've made your IAM policies very, very particular, if it ever gets compromised, the attacker is able to use it from absolutely anywhere. The AWS APIs are really intentionally public. So we also know that attackers are looking for them all the time. This is a quick little experience that I did. I encourage you to do this to yourself. Go to canarytokens.org and you can spin up a honey token, which is a legit set of AWS access keys. And then as soon as somebody accesses them, you get an alert. So I make myself a fake set of credentials. I commit it to a randomly brand new GitHub repo. And 12 minutes later, somebody's already trying to go after them. So how do we get rid of these static access keys? Well, we know they're everywhere. We know that they have some problem. There's kind of three big ingredients that we need to be able to mix together in order to kind of finally kill these things off. So the first ingredient that we need is the AWS Security Token Service. And the AWS Security Token Service is a native API that returns back to you these ephemeral access keys. They can live anywhere for a couple of minutes, up to about 12 hours. And once their time to live is done, they turn into a pumpkin. Poof, go away, which really dramatically reduces the blast radius for some compromised credentials. But there's a bit of a bootstrapping issue because I need AWS credentials to be able to get AWS credentials. So how do we solve that one? Well, the second part of this that we need is the Security Assertion Markup Language, or SAML, which is written in XML. And you might be looking there and say, couldn't you get a much more high-res version of a SAML assertion? I said I could, but if I have to look at that much XML all at the same time, my eyes start to bleed. So I fuzzed it over for everyone's safety. So for as much as I dislike actually looking at XML, it's really functional. It's been around for basically forever. And the part that I find most helpful about SAML is it doesn't actually require a direct network connection between the service that you're logging into and the identity provider that is validating the identity. So let's walk through a sample SAML login flow. So one of the ways this most commonly works is the client's going to go into the service that they're going to try to log into. The service says, you're not logged in. Let me redirect you back to your identity provider. So the client then goes back to the identity provider, signs in, and the identity provider provides a cryptographically signed SAML assertion back to the client. The client sends that on to the service, who validates that that is in fact a valid SAML assertion from the trusted identity provider, and they log in. Now, what you don't see here are any arrows that actually tie together the identity provider or the service. There is a trust relationship that's implied because of the cryptographic signing of the assertion, but you don't actually have to poke holes in your firewalls for these things to be talking directly to one another. And the reason for that is when you're setting up the ability to sign in by SAML, one of the steps is going to be adding this metadata and giving it to the service. And there's lots of different things about this that says, hey, what are the types of things you should expect in a valid SAML assertion? How should you parse it? Where should you redirect people to that aren't actually signed in? But the big chunk of this you can see is a big old certificate, which is how the service is able to figure out that the SAML assertion sent to it is in fact from a legitimate identity provider and not someone typing randomly into Notepad. So, great. We have the security token service, we have SAML, and our third ingredient is the AWS native API, assume role with SAML, which mixes this together like peanut butter and jelly. And all you got to do is send AWS a validly signed SAML assertion, and you get back security token service. So we're done. It's great. In fact, all you need to do is tell your engineers that they have to open up something like SAML Tracer to be able to figure out all of the network connections going back and forth. Click on the little icon for the SAML, figure out which one of these particular network requests had the SAML assertion, go over and pull out that, drop it into your terminal, pipe it into base 64, so you get the base 64 encoded SAML version, and then drop it at the end of this big old massive command, and oh my gosh, that's a lot of base 64, at which point they get the error that they didn't do that fast enough and the SAML assertion has expired, by which point all your engineers are saying, isn't there a free trial version of GCP that doesn't make me need to do all this madness? So obviously you need more than just those three random ingredients. So what I'd like to do now is talk about how we did this specifically at my company. So I am going to mention vendor names because those are the vendor names we use, but it really doesn't matter what vendor names you happen to insert here. So for example, our identity provider at ASAP is Okta. You can use Okta. You can use whatever you want. As long as it speaks SAML, you're fine. And there's 1,001 other identity providers out there. G Suite, Ping Federate, Duo has their own South Gateway. As long as it speaks SAML, which basically everything for the past 15 years with enterprise single sign-on does, you're good. And then you also need something that's going to take that and make that entire 10-step process a little bit more brainless and simple for your engineers. So the command line tool that we ended up using and choosing at ASAP is AWS Octave. However, I cannot recommend that you also choose AWS Octave. In fact, if the second line of a GitHub project's README is, if you're not using this, you probably don't want to start. You probably don't want to start using it. So don't use that one. But I have to say, I'm not actually all that worried that this particular command line tool is going on indefinite hiatus, because now that we've already got all the plumbing that we need for the identity provider and IAM roles that people are signing into, we can actually swap out what particular command line tool that you're going to be using without too much difficulty. So I'm going to talk about this kind of as an example of what you can expect out of similar command line tools, because as you've listed down there, there's many other options. And we use Terraform as infrastructure as code. I'm going to use some of that up on the screen, mostly to show you that it's really not that hard. You can do this in a handful of lines of Terraform. But you don't have to use Terraform. If all you like is clicking around manually in the GUI, you can still get a big security win without too much work. So again, I go through these a little bit faster, and oh shoot, I missed a slide, I wanted to take a picture. Every single one of these slides is already up and attached on Sketch. All of the Terraform code that you see here is already up in a public repo. It's also modularized, so you can just steal it whole scale and plug it right in. You don't need to actually be writing things down as we go on down. So the first step is setting up the actual identity provider. And again, I'm saying that we use Okta, and I'm going to be a little bit hand-wavy because Okta actually has pretty amazing step-by-step documentations. But on a high level, once you've set up the app, you got to download that metadata.xml that I showed you before, shows the public certificate and some of those odds and ends. And then literally 4 lines of Terraform sets up that identity provider in AWS. So once you've actually created that identity provider inside AWS, you got to find the ARN, copy it back into Okta, and that's all the setup you need to do. Seriously, 3 slides. Now for Okta, they also want an API integration that's going to make your life a little bit easier. This is a user that Okta uses to go in and query and figure out, okay, what roles are assumable from this particular identity provider, from this particular Okta app. And it makes the role assignment and doing things in the Okta GUI a lot simpler and smoother. And again, a handful of lines of Terraform here. You got one resource to create the user, another one to create and attach the policy, and you can see there the rights that it needs is really nothing too radioactive at all. A bunch of an IAM read permissions mostly. And in irony of ironies, in order to get rid of static access keys, I have to give Okta static access keys, but let's not make the perfect be the enemy of the good. This can still be a net win here. Now, once you've done that, now you need to make the new IAM roles that you want assumable from this SAML provider. And it might look a little bit more complicated than it actually is here. It still fits on a PowerPoint slide, but the main chunk here that's important is the IAM policy that states this role is assumable from that SAML provider. And if you attach that as the assume role policy for whatever role you're using, then you're good. Now, again, we're going to go quick over AWS Okta. Again, I do not recommend to start with AWS Okta, but as an idea of how simple these types of command line tools are, installing it is like a line. Adding in the Okta creds is one command. It's going to take the username and password and the config information of what Okta.org stored in the macOS keychain. And then you have to do a little bit of a tweaks to your AWS config. 99% of the AWS config file is the same stuff that you've done all the time before. You have roles. You can have secondary roles that are assumed from other roles. The main deal is there needs to be like a little bit in there somewhere that specifically outlines the SAML URL. You can pull that out of the XML metadata. That just points the command line tool to the right place that it should go to try to pull a valid SAML assertion from. Now, we haven't even talked about MFA, yet another benefit of killing off static keys. Most of the command line tools that you will see out in GitHub all natively support dual push, time-based one-time password, some of the Octave native apps, not seen too much U2F. But the way that AWS Okta does that is during the first initial attempt to use the command, it will log into Okta and keep a session cookie. So only the first time that your engineers are using this will they be prompted for an MFA push, and then they're fine for however long you want to set the length of that session cookie. And the way that it delivers these security token service credentials is by dropping them as an environment variable. So for AWS Okta, you can see the execution style there where you say AWS Okta exec and whatever profile name you want to assume. And if I pop that into environment, you can see there's a whole bunch of AWS-specific environment variables which are local to that command and disappear as soon as that command is done. Now, if you're using the native AWS CLI, Bodo 3 Python library, or any of the other AWS natively supported methods of working with the API, they'll automatically check these very specific environment variables for the credentials that it needs to execute. You also see that it has the session token and security token as the same thing. One of those got legacy and deprecated, and they just give it both to you just in case the tooling that you use is looking for the old one. And this is how this worked out here at ASAP for our particular architecture. So we're going to start down in that lower left-hand side there, where if you start out with AWS Okta, it's going to invoke the command, it's going to pull out the credentials from the macOS keychain, send that into Okta to get back that valid SAML assertion. And at ISAP, we had too many AWS accounts, quite frankly. So we solved this problem by creating one more. And this one that we created is a centralized identity account. And this identity account has absolutely nothing in it besides IAM roles. So the Okta SAML assertion is traded to the identity account for a valid security token service credentials for one of those central identity roles. And then once you have one of those central identity roles, you can cross-account a role, assume a role in any other AWS account that corresponds to that, which then those security token service credentials are injected as environment variables back into your original command. Now, a little bit of a note here. We found that at ASAP, having this idea of a central identity account was really helpful for us. It dramatically simplifies the number of Okta role assignments, made my help desk people much less confused. It means that they can just take one Okta group and assign it to one identity role, and they're done. It's really easy to understand rather than clicking through with every single one. It's also been particularly helpful when it comes to tracking things down in incident response, that I know that if any human being has taken any action anywhere in one of my AWS accounts, there's always going to be some initial CloudTrail authentication log that is inside the identity account. That's been really helpful as a resource. That said, there's a big drawback as well. Normally, security token service credentials can last up to 12 hours. But if you use IAM role chaining, which is this, I assume a role and then I use that IAM role to assume yet another role, the max time to live for those security token service credentials is only an hour. Because AWS reasons, I don't really know. I just know that this has been a pain point occasionally when we've been working things through. We've had processes that normally last longer than an hour, or a number of different times where it'd be really nice to be able to just tell an engineer, generate your creds once for the day and then don't need to worry about it. We had to put a little bit more wrench time in for some of the scripting that we had for these types of longer running jobs to automatically update and renew those credentials. Just something to think about and consider as you might be building this out at your own orgs. If you have a small handful of AWS accounts, say 5 or less, I might recommend that you go with just direct role assumption rather than role chaining. And then some other odds and ends that were helpful from our rollout. Like an idiot, the first time I started doing this, I tried to maintain this AWS config file manually. Don't do that. That's dumb. The number of different ways that you can screw up a config file by hand is pretty long. And the more that we were able to automate this, I mean, it was a Python script we kind of kludged together in a couple of hours, being able to standardize the same AWS config file across the entire org has been really helpful for troubleshooting. You can have a whole bunch of different roles that aren't actually authorized for the person to use without hurting or harming anything. And it just, the standardization really helps. Ultimately, we ended up with a couple thousand lines of a standard AWS config file. We push it out through central management. It works really smoothly. I think the second lesson that we learned from this was, as I was making these very specific IAM roles for humans to assume, I also needed to cover the use case of how to get AWS authorization on the EC2 instances. And previously, engineers were copying up sets of their static credentials that they had on their laptop up to EC2 instances, which, yeah, again, not great. I'd really recommend that as you're building out these new IAM roles, assumable from SAML, make an equally privileged, equally named instance IAM role that your engineers would be allowed to assign to the EC2 instances and is then accessible through the metadata URL. Again, if you're using Bodo 3 or the AWS CLI, checking the metadata URL for EC2 instances and getting security token services is all natively supportive. They don't have to change a thing. And then I think the last lesson that I learned that was a little surprising is, while I certainly went out and started pushing this as a security win, about halfway through the rollout, I started getting back pressure from the business to go even faster. And the reason for that is they realized the benefits here of how much quicker this ended up being for onboarding. I mean, the old process was you get a new hire, you open up a Jira ticket, you assign it to SRE, you poke them with a stick over Slack until somebody maybe gets stuff together. Oh, but it's done manually, and so maybe they didn't get the right group permissions. That's all a thing of the past, where an employee who's new hired automatically gets an Okta account. That Okta account is automatically assigned to the right group that they're working in, and then that group already automatically is authorized to the correct set of AWS roles. So an employee within 10 minutes of showing up and open up their laptops could be executing commands in AWS. And as a security person, I like the flip side of that better, which is the deprovisioning is also instance. It's really nice to know that as soon as my help desk team shuts off the account in the central Okta identity provider, everything else with AWS is shut down too. So that's what I have. If you guys have questions for me for the little bit of time that we have left, go ahead and open up Slido, that hashtag BSidesSF 2020. I'll answer as many questions as people have right now. And if we run out of time or there's other things you want to ask me, my contact information is on the screen. Thank you very much. Hey.
Question. Oh yeah, I'll ask a question. So someone just asked a question, and maybe you want to speak to this in the context of your talk. But someone just asked, what are some best practices for AWS cloud security? So maybe if there's something else about securing access keys you can think of.
Sure. Best practice for AWS cloud security. I feel like that is an entire talk in and of itself. Log all the things, patch all the things, get visibility to all the things. Come back next year, or maybe I'll do a talk on that one.
Another question here. How do you address a single point of failure scenario if the external SAML IDP or identity provider APIs go down for some reason, as an example?
Yeah, I think this is absolutely valid. So for our company, our emergency break glass is the root account. And in our particular situation, the way that we've handled that is we've done kind of a 2 keys to launch nuke kind of deal where the SRE team has the passwords needed to log in as root and the security team has all of the multi-factor seeds. So you can't just break glass because I was a little bit annoyed with Okta, but like in cases of a legitimate emergency, we can still sign in and get into our accounts. I do think it's always good to think about the break glass scenario, and quite frankly, my company goes down a lot more than Okta goes down, so it hasn't actually been a practical consideration that we've needed to worry about.
Another question just came in. Any tips on rolling out these changes when each team has their own AWS accounts?
Yeah, that's a great question. I think one of the things that I've also struggled with is this idea of kind of fragmentation of ownership, where it's really nice if you have like one central SRE team that owns all the different things. But I think the thing that I would say is that even if you the ownership of the AWS accounts is owned by lots of different teams. Even if you don't have that, you're still going to have specific team processes that need to adapt to the new way anyway. Being proactive about your conversations with each team and understanding their AWS use cases and make sure they feel comfortable in everything they can do with the new one is definitely going to be a step in your right direction. The easier that you can make this, the better. And if you need help from an authorization from multiple different teams to actually implement these changes, then using something like Terraform to make it modularized and simple to say, look, if you don't even want to think about it, just run Terraform, apply, and go. The simpler that you can make this, I really would argue with everyone that I was trying to do with this, look, this is going to make your lives easier. It's not just a security win, but it's going to make your lives easier.
You're getting a lot of questions here, man. So someone just asked, you mentioned about IAM creds being used anywhere on the AWS API. Can you speak to limiting this? And they provided an example of allowing AWS API calls from within an Office network or VPN.
Yeah, so if you want to go down this path, there is ways in which to do this with IAM conditionals, where you can do things like, here are the rights granted for these resources with these actions if the source IP is one of these source IP ranges, or if the VPC that you're doing this from is one of these VPC ranges. You got to be really intentional about these things, though, because it's obviously really easy to break stuff. The defaults are always wide open, allow it anywhere in the world, but there are some fiddly bits that you can fiddle with if you want to make that, in fact, not be the case. I think we have one more minute, so maybe one more question.
Where and how do you retain the master creds, and is that done differently between security teams and DevOps teams?
So yeah, I mentioned the master credential for an AWS account is the root user. And the root user, I don't even know if it's possible to make assumable from SAML, but I wouldn't recommend it even if you could. That particular user, again, in my instance, we split up the 2 sets of credentials needed to sign in. So one team has the password in a dedicated, encrypted, offline password vault. A second team has the MFA tokens needed. And again, those QA seeds are stored in a separate encrypted offline password vault. And then only when those two things are able to go together can somebody sign in as root. If you guys have more questions, again, Twitter handle, email up on the screen. Please reach out. I'm happy to answer whatever other questions you have. Thank you for your time, everybody, and let's go get lunch.